Okay guys, we've got one built here and we've got one that we haven't put together. I'm going to show you just how this goes together so you can see it in your mind, okay, and how it works. Because the directions are very good, but you have to really pay attention to every word here and all the arrows. It's a little hard to see, especially with my older eyes, but the directions, and they're a little bit out of order, so we're going to talk about that. I do want to talk about the mistakes we made, especially because we didn't make all the mistakes with this that you can make, but we made some, and we're going to talk about all the mistakes at least, though, okay? Or at least most of the mistakes you can make. And I'm not like a fabricator, but I'm not a beginning welder either. I've welded a lot of things over the last 30 years, and this has a few tricks to pay attention to, okay? So let's get into those. All right, so this one's complete right here, and there's a few things to pay attention to. You can see that this is where this nut needs to end up, because this is what indexes into your pins on this, okay? And that's what that looks like. It goes all the way through, so I was worried it's open on that side, and I was wondering, should I weld that in? But I don't think anybody's doing that because it still seems to be plenty strong. And so you can adjust it, of course, up and down, and it's nice and flush, so that's the right distance. Which side you put this washer on and weld it on is important. How much you weld around it's important, okay? Leaving that nut off when you're welding it on is important as well. How much to weld this around. You know, we welded this cross rod here on the outside and the inside. We welded everything on both sides that we could. Where you don't want to weld is in this side here with the small holes, okay? So don't weld that joint and that joint, because that will interfere, or could potentially interfere with it sliding up and down here, okay? And so this is what slides against the jack side, so make sure to not weld there. So I'm just going to put this together so you can kind of see how it goes together, almost like a little puzzle. All right, so this vertical piece goes right here, okay? This piece with the fork goes forward toward the big hole here. Now, eventually this will be welded in once you're assembling this for final welding, but this is how the bolt looks. And the nut, not going to get that screwed all the way down, but basically the bolt head goes toward the small hole, the nut goes toward the big hole, and the big washer, the big steel washer, goes toward the big hole as well on that side, okay? So we can just leave that sitting in there. This piece you can drop in right here, and it's pretty tightly engineered, so you got to kind of finagle it, you know, mess with it a little bit to make sure it fits tight. Now this cross rod just slides through here like that, okay? Now let's pay close attention to this, because you can see that once you have it in your hands that there's some play here, okay? And you don't want to get your holes misaligned on either end. So how do we keep from doing that? The way we did it on the first one worked really well for us. And so what we did was we took this and set it in place. We took the little bolt that goes in the back and ran it through as well. That helps keep it in alignment. But I think the most important thing is setting it on a flat surface here, okay? Because that kind of lines everything up. That lines up this with this as far as that goes. All right, and then we took our clamps and clamped it in a couple places before we tacked it. Okay, now you clamp it here and it's going to try to spread back here, right? So we got to clamp it sort of right past this piece, like here. Maybe a little bit tighter there. Okay, now look at that. Either my table's crooked or it moved a little bit when I clamped it. So let's unclamp it. Just kind of hold it in place there. Clamp it there. Clamp it there. Now there's just a tiny bit of rocking, just a tiny, tiny bit. Now the question is, will these slide in and out easily? They don't cross over. They're not jamming. We're not having to drive anything in. Now that we have it true, I would go ahead and tack it here, 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 then flip it over and tack it on the other side, and just get it tacked in. Maybe tack these outer sides as well, these outer holes. And then once it's all tacked in, we can take the clamps off and then start getting it burned in. Actually, you know, on this first one, we left the clamps on as much as we could just to make sure it stayed nice and true. And this one's pretty good. And obviously, before you're going to assemble this, you're going to flap disc this down. Or we didn't use a grinder. We used, I think, 120 grit flap disc, which worked well, made it nice and shiny. Got all the mill scale off where we wanted to weld. So we just pretty much did the whole thing. You can see from here over on both sides of this, and all over on both sides of that and both sides of that bracket, the ends of this piece right here, and of course the washer as well. We did the washer. Now, something else to pay attention to when you're welding this up is what happens when you tack this washer in and then you take your bolt out and then you're burning this in. Right here, when you weld around this washer, the tolerance between this plate and the washer is very small right there. So we actually had to grind that out to get this piece to fit together. And of course, if you're assembling it, you'll be like, why won't this piece go in? Or why can't I get it together? And it's because your weld there is too tall. Now on this one, this may not be very visible, but we had to grind the weld out on this side of the bolt back here, right there. We had to grind that weld out before we assembled it. Now, another mistake we made on this first build was we, of course, squared this up. We're going to go over that later in the video, how we did that. You don't want this piece too high up here because the ears on the side of your foot kind of angle up, and then you won't be able to get it in place, okay? So you have to sort of set this in place, put your foot on this highest pin here, right here, and then slide it up until the ears on the side hit right there. And then we just dropped it down maybe a couple millimeters, and that's where we clamped this piece right here onto the jack itself. Okay, that gives the foot plenty of room. Okay, so once we got this centered, we used the caliper and the little rod that slides out the end of the caliper to center it perfectly. And we got it clamped down. We clamped it once in the middle, once on the end here. Double checked the foot. We also double checked the tolerances to make sure it was centered again. We like double and triple check this to make sure it was perfectly centered. And then we had 3 clamps on it, 1 high, 1 in the middle, and 1 low. Now, when we went to burn it in, we tacked here, and then we tacked both sides of the middle pretty quickly to try to keep it from lifting. And that's another thing you want to pay attention to, is you really want to tack it quickly so that as it cools and shrinks, it doesn't try to warp your metal or cause this to flex out. So when you go to tack it on the side, make sure it's still nice and tight against your jack body, okay? Then as we welded it in this position, and I wouldn't recommend that now, looking back, because what happened to us was, as my nephew's welding this, you know, he burned in one side here, burned in here, burned in here. And we really didn't let it cool much, and we thought that was a problem, but I don't think it was that big of a problem in the end. Then he welded this side here, and then came back and kind of staggered here, here, across, here, here. And then, so we got it all welded in, we got it all together. We went out to test it before he went to paint it, and then we were like, whoa, it won't jack at all. And we were cranking on the jack, and it was totally frozen between this piece and this piece. And we thought, oh, we didn't allow enough cool time, and it melted all the paint inside, and the paint's all fused, okay? So we broke it loose. We finally got it broken loose, and it was real resistant for the first, like, I don't know, maybe 4 or 5 inches of travel, and then it got real easy. So we thought, oh, we melted all the paint inside, and there's no way to really get this apart without taking it apart up here, which we did. But looking inside, we found out that, yeah, the paint melted inside, but that wasn't the problem. The problem was way up in here, in one of these welds, it had gotten hot enough to burn through or to melt out on the inside of this thinner steel of the jack, okay? And it made a little knob inside. It melted just enough, and I don't know if my nephew welded through or welded a hole. He never mentioned that he saw a hole that he had to fill, but if that happens, you got to be super careful because you can't grind this out inside, all right? So that little knob caused this piece right here, as it slides up, it slid up fine, and once it hit that little knob right in the corner, it would kind of jam and it would get real resistant. Okay, so, you know, looking up inside here, in this upper corner up here, it might not come out on the camera, but I can see a little knob, a little bump, a little piece of metal that's kind of melted through where we got a little too hot when we were welding, and it melted a piece through there. And it's just a little bump, but it's enough to catch this piece as it slides up inside there. And so in this corner up here, that's right where this side slides, and you can see right there where all the paint's worn off as it's gone past there, okay? So that's where it's really binding, is right there. There's no way to get that out now unless I cut out the weld and cut out the piece and re-weld it back and hope nothing drips down inside. I think that's too much drama. I'm gonna go ahead and try to salvage this by just go ahead and grinding right here in this upper part, maybe from here to here, and grind that down just a little bit. Just take a little edge off there, put a little bevel on that, and hopefully that will take care of it and it'll slide better. But it took a little bit to wear it in. I had to make a few runs up and down, up and down, up and down to get that to wear in. So don't make that mistake. So the way we're going to prevent it on this one, when we're welding this, is because this is thinner steel on the jack tube and this is thicker steel, we're going to remedy that. Let me show you how. Okay, so I got a little excessive stick out, but that's just for an example here so I can show you what we did or what we would do different on the next one. Now, you know, you got a 90-degree angle here. So before this was welded, this was 90 degrees. And I tend to use just like 45 degrees. And I tend to do cursive E's just because that's what I was taught as a stick welder from 30-something years ago. And so I'll start in the bottom, build my heat, kind of wrap up, and then catch this metal, and then come down and catch this metal. Well, I'm spending a lot more time on the base metal doing that. And that's how I taught my nephew, because it's an easy technique. It's not hard to learn. None of our welds are perfect, but when we're dragging down, a lot more of the heat is staying on this thinner metal, okay? And so in that cursive E technique, we're spending less time up here and more time down here. And so that's sort of what it's looking like, right? And so we're spending more time burning here on this thinner metal, which can cause it to deform inside or even start to melt through and cause a little bubble or a little bump on the inside. And that's kind of catastrophic for this jack. So you want to be careful with your welding. Now, what we're going to do to remedy that is two things. One thing is we're going to stand it up on its end like this on this next project, so that when we spend more time at the bottom, we're spending more time on the heavy steel. This is 1/4 inch, and this is probably 1/8 inch right here. Okay, so this 1/4 inch steel, we're going to spend a little more time there, and then just drag up and catch the 1/8 steel. Spend more time melting the 1/4, less time on the 1/8 inch, and just more time down here, less, more, less. If that makes sense. The other thing is, you know, we set our settings to basically a 1/4 inch thick welding setting. You know, this is 1/4, this is 1/8. I think we're going to strike a balance and just use a 3/16 setting. I don't want to use a 1/8 setting because I want to make sure we're getting this penetrated well. But also, I don't want to over penetrate this. So we're going to use a 3/16 setting and still use that cursive E technique probably, or whatever Luke's comfortable with. And hopefully that'll be a good balance and we won't melt through. I encourage you to always check your gap. Make sure you don't have a gap here as you're welding it, because you can fix it before you weld it. But once you have a gap here, let's say you have a gap here, it's going to be crooked here and it may not index well later. Okay, and the directions, everything's here, but to me this was a little bit out of order as far as what to do, and it was a little confusing to me until I watched some videos and kind of had to pay more attention to it. As far as this goes, this is part number 1. Clean the paint from the jack before welding. Sand every weld location on laser cut parts to clean metal. So you want to clean all these pieces, right? And go ahead and grind this part. That's step number 1. They mention right here, weld every flat location on the TJ pin plate to the jack body. Allow extra time for cooling and move around for location. Okay, so you can't weld this pin plate on the jack body until you build this thing, okay? Because this is how you locate that. That's how you make sure when you tack weld this on, or when you clamp it on, and then you test fit your foot on that, you have to have that assembled. So go down here, do that first part, but then come down here. It says fully weld entire circumference of TJ pin weld washer to the TJ pin mount. So this is the weld washer, and this is the pin mount, okay? So you want to weld this onto here. Use the socket head bolt for centering. Then it says grind the TJ brace for weld clearance if required. So this TJ brace for weld clearance is what they're talking about. If you burn this in all the way around and your weld sticks out all the way around, you're going to have to grind one edge of it right here so that it'll actually fit together. This is the third step here, the nose assembly, or what I've been calling the foot. The tab and slot system will align everything when clamped to a flat surface. Plug weld all 4 tabs, blah, 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 blah. So you can do this part, and then you want to come back up. This is number 4 here. Then weld every flat location on the TJ pin plate. This long piece is the TJ pin plate. And then you want to weld every flat location, okay? So I see people burning in right here in this middle part. I don't know why they're saying just weld the flat location. Except that if you weld in here, that may cause it to warp, and this is more structurally sound out toward the edge here. That's a guess. Okay, it's all welded on. We're going to see, we know it fits, but we're just going to put it together here and how this little camming lever goes. And then this bigger washer goes on this side.
Put this.
Yeah, and then that goes inside this. And I'll hold the nut on the other side. Actually, I can turn the nut from the other side. That's a little easier if you turn the nut from the other side rather than trying to turn that. You threading up? Yep, seems to be. So this has a narrow side and a wide side. So right now it's on the wide side, so that's the cam side, right? And you can uncam it by turning it. So the narrow side, see the narrow side right there, fits toward the jack, and then you can tighten it up and then tighten it wherever you want. All right. Looking good. Upper, oh, there's the hole right there. Okay. Well, this one cranks a heck of a lot easier than the last one.
Yeah.
It sounds like you didn't burn through the metal. That's good. It's probably a little stiffer than the original jack, is my guess, and that's just because there's melted paint inside that you're kind of overcoming. So, you want to try it out on the Jeep first? Or the Taco, or?
Let's try it on the Jeep.